Welcome to Ask and Learn.
Let's first check whether this series is absolutely convergent. So to do that, instead of looking at these terms here, we replace them with absolute value. So absolute value of -1 to the n is just 1. And everything else stays the same because n and natural log of n are both positive if n is bigger than or equal to 2. And excuse me here, this should not be a 2, this should be an n. Sorry about that. So now for this series here, I would use the integral test. So we would look at the integral 2 to infinity 1 over x natural log x. The reason I would do integral test here is because if you replace n with x's, this could be integrated using a u substitution. So before that, let's bring this over here. Let me rewrite this as an improper integral. And then I would go ahead and do a u sub here. Let's try u equals natural log of x. Du is 1 over x dx. So we'll keep that limit. The limit will stay until after we evaluate the integral. So now using our u sub, you could take these x values over here and plug into this formula to find your u bounds of integration. And then the integral becomes 1 over u du. Natural log absolute value of u. U goes from ln2 to ln k. And as we take the limit, natural log of k goes to infinity. And so therefore, the natural log of this will also go to infinity. Whereas we'll have over here, natural log of 2, which is not infinite. It's just a number, so when we do infinity minus this number, we still get infinity. So the integral does not converge. This means that this series over here, not the original, but the modified one, this one diverges. So we can say that our original series is not absolutely convergent. But then it's possible that it's still conditionally convergent. So let's go ahead and check this. Let me go on to the next page. So the question now is whether it's conditionally convergent. So here, let's try, we see that this is an alternating series. So let's try the alternating series test. So here we can define Bn to just be 1 over n natural log of n. So we're taking absolute value here. And then notice that this is positive since n and natural log of n are both positive if n is bigger than or equal to 2, which is the case in our problem. So that's one condition of the alternating series test. The next one, you need the limit of the Bn to be 0. In our case, both of the factors in the denominator go to infinity. As we take the limit, so the fraction becomes 1 over infinity, which is 0. And finally, we need to check that the bn's are decreasing. So how are we going to verify that? So one way is to just convince yourself that this equation is true. In our case, and this is equivalent to n natural log of n less than or equal to n plus 1, natural log of n plus 1. And the latest inequality is true because n is less than n plus 1, and natural log of n is less than natural log of n plus 1. Now, since these are all equivalent, that means that this is true, which means that Bn is a decreasing sequence. So we conclude that the series converges by AST. And since we already showed it wasn't absolutely convergent, the answer is that it's conditionally convergent.